Cosmic billiards when planets collide. Space is vast. It seems like planets are incredibly far apart. While true, collisions do happen. Imagine a cosmic game of billiards played over billions of years. These collisions are rare, but they leave lasting marks on solar systems. Understanding them is crucial to understanding our own planet's history. Planetary collisions are catastrophic events. They can reshape worlds, create moons, and even influence the evolution of life. The evidence of these cosmic crashes is scattered throughout our solar system, hidden in plain sight. By studying these remnants, we can piece together the story of our solar system's violent past. The early solar system, a chaotic dance. Our solar system wasn't always the calm and orderly place it is today. Billions of years ago, it was a chaotic and crowded place. Planets formed from a swirling disk of gas and dust surrounding our young sun. These protoplanets, as they're called, jostled for position, their orbits intersecting in a celestial dance. Gravity played a major role, pulling these objects together. Some collisions were minor, nudging planets into new orbits. Others were cataclysmic, resulting in the complete destruction of one or both bodies. These collisions were a defining feature of the early solar system, shaping the layout we see today. The Theia Hypothesis, birth of the moon. Perhaps the most famous planetary collision is the one that scientists believe formed our moon. This is known as the Giant Impact Hypothesis, or the Theia Impact. The theory proposes that a Mars-sized object named Theia slammed into the young Earth billions of years ago. The energy released from this impact was unimaginable. It would have melted the Earth's surface and vaporized Theia entirely. Debris from this cosmic crash was flung into space, eventually coalescing under its own gravity to form the moon. Reconstructing the past, evidence of impact. The Theia impact happened billions of years ago, so how can we be sure it actually happened? The evidence lies in the composition of the Earth and the moon. Lunar samples brought back by the Apollo missions revealed a startling similarity to Earth's mantle. This suggests a shared origin, supporting the idea that the moon formed from material blasted off the Earth. Furthermore, computer simulations of the impact align with the current Earth-Moon system, adding further weight to the theory. Section 5. A molten Earth, the aftermath of collision. The impact that formed the moon would have had profound effects on the early Earth. The energy released would have melted the Earth's surface, creating a global magma ocean. This molten state would have lasted for millions of years, slowly cooling and solidifying over time. The impact also likely played a role in the formation of Earth's atmosphere. As the molten rock cooled, it released gases that eventually formed our planet's early atmosphere. This catastrophic event, while destructive, set the stage for the evolution of life as we know it. Section 6. Formation of the moon debris into a celestial body. After the impact, debris from both Earth and Theia orbited our planet. This debris field, a chaotic mix of molten rock and vaporized material, slowly began to clump together under its own gravity. Over millions of years, this process continued, with larger clumps attracting smaller ones. Eventually, this process resulted in the formation of our moon. Initially, the moon was much closer to Earth and appeared much larger in the sky. Over billions of years, tidal interactions have caused the moon to slowly drift away, reaching its current position today. Section 7. Life as we know it. The role of the moon. The moon, a celestial offspring of a cosmic collision, has played a vital role in the evolution of life on Earth. Formed around 4.5 billion years ago, it has been a constant companion to our planet, influencing various natural phenomena. Its gravitational pull creates tides, which influence ocean currents and marine ecosystems. These tides are not just a rhythmic rise and fall of sea levels. They are a driving force behind the movement of nutrients and the behavior of marine life. This tidal influence is thought to have played a role in the emergence of life from the oceans. The intertidal zones, where the ocean meets the land, provided a unique environment for early life forms to adapt and evolve. Furthermore, the moon's gravity stabilizes Earth's axial tilt. This tilt is responsible for the changing seasons, which in turn affect the entire biosphere. This stability is crucial for maintaining a stable climate, a key factor in the development of complex life. A stable axial tilt means predictable seasons, which allow ecosystems to thrive and biodiversity to flourish. Without the moon, Earth's climate would be far more chaotic, potentially hindering the development of life as we know it. The absence of the moon could lead to extreme weather patterns, making it difficult for life to sustain and evolve in a consistent manner. Section 8, Ceres, Scars of a Violent Past. The surface of Ceres, the largest object in the asteroid belt between Mars and Jupiter, is a testament to the tumultuous history of our solar system. The Theia Impact, which is believed to have formed our moon, is not the only example of a planetary collision in our solar system. Such cataclysmic events have shaped many celestial bodies. Ceres, a dwarf planet residing in the asteroid belt, bears the scars of a violent past. Its surface is a mosaic of craters, each telling a story of ancient impacts. Its heavily cratered surface tells a story of countless impacts, each collision adding a new chapter to its history. These craters are not just random marks, they are records of the dynamic processes that have shaped Ceres over billions of years. Some of these impacts were significant enough to leave lasting marks, altering the landscape of Ceres permanently. The size and distribution of these craters provide clues about the size and speed of the impacting objects. One particular impact basin on Ceres, named Kirwan Basin, spans nearly 2,000 miles. This massive crater is a focal point for scientists studying the history of impacts in the asteroid belt. This massive crater is evidence of a collision with a large object, possibly a protoplanet, early in the solar system's history. The force of such an impact would have been immense, reshaping the surface of Ceres and leaving a lasting imprint. By studying these impacts, we gain insights into the formation and evolution of the asteroid belt. Each crater is a window into the past, revealing the violent events that have shaped not only Ceres, but the entire solar system. Through these studies, we continue to unravel the mysteries of our cosmic neighborhood. Section 9. Asteroid Belts, Remnants of Collisions. The asteroid belt, a vast region of rocky debris between Mars and Jupiter, is thought to be the remnants of a failed planet. The gravitational influence of Jupiter, the largest planet in our solar system, prevented these objects from coalescing into a single planet. Instead, these objects continued to collide, breaking apart into smaller and smaller pieces. The asteroid belt serves as a reminder of the chaotic nature of the early solar system and the powerful forces that shaped our cosmic neighborhood. Section 10. Planetary Defense. Learning from the past. Understanding planetary collisions is not just an academic exercise, it has real-world implications for the survival of our species. While large-scale impacts are rare, they are a real threat. By studying past impacts, we can learn to identify potentially hazardous objects and develop strategies to mitigate the risk of future collisions. Space agencies around the world are actively tracking near-Earth objects, such as asteroids and comets, that could pose a threat to our planet. By studying their orbits and compositions, we can better understand the risks they pose and develop strategies to deflect or destroy them if necessary. Section 11. Future collisions, a matter of when, not if. While we haven't observed any major planetary collisions in our solar system in recent history, it's only a matter of time before another one occurs. Space is vast, but it's not empty. Objects are constantly moving, and their paths will inevitably cross again. The good news is that we are becoming increasingly adept at detecting and tracking potentially hazardous objects. With continued investment in space exploration and planetary defense, we can hope to be prepared for the next cosmic event, whenever it may occur. Section 12. Conclusion, Collisions, and the Cosmic Ballet. In the vast expanse of the universe, collisions are not just random events, but are integral to the cosmic dance that shapes everything we see. Planetary collisions are a fundamental aspect of the universe we inhabit. These monumental impacts are responsible for the birth and death of celestial bodies, influencing the architecture of galaxies and the formation of planetary systems. They are agents of creation and destruction, shaping the evolution of solar systems and the worlds they contain. Through these violent encounters, new planets can emerge, and existing ones can be dramatically altered, leading to diverse and dynamic planetary environments. From the formation of our moon to the scars on Ceres, the evidence of these cosmic crashes is all around us. The moon itself is believed to have formed from a colossal impact between the early Earth and a Mars-sized body, leaving behind a satellite that has influenced our planet's tides and climate. By studying these events, we gain a deeper understanding of our own planet's history the dynamics of the solar system, and the forces that shape the cosmos. Researchers and scientists use advanced technology and telescopes to observe and analyze these collisions, piecing together the story of our universe's past. As we continue to explore the universe, we are sure to uncover more evidence of these cosmic collisions, each one adding a new chapter to the ongoing story of the universe. With every discovery, we not only learn more about the cosmos, but also about the intricate and interconnected nature of existence itself. The cosmic ballet of collisions is a testament to the ever-changing and dynamic universe we are a part of.